Welcome to lecture 5.1, where we will be diving into isomerism. So let's define this word isomer. So isomers are molecules that have the identical molecular formula, that is, they share their atomic makeup. However, they differ in some fundamental way. So they're not identical molecules, they're going to have different names and potentially very different properties. So this term isomer can generally be broken into two groups. Today we're going to be focusing on the constitutional isomers. Another word for these you might see is the structural isomers. And these isomers are much more straightforward than the stereoisomers. Structural isomers have the same molecular formula, but the way that those atoms are connected is simply different. So these molecules have different names, and typically they have different chemical properties as well. As an example, let's start with a small molecule, C3H8O. So we can imagine drawing 3 carbons, like so, 1 carbon at every vertex. And we can put an oxygen somewhere. So we could say, well, let's put an alcohol here. Now we could say, well, let's see if this structure I came up with has the right number of hydrogens. You'll see that hydrogens are actually going to be probably the hardest part of this unit, and that's where lecture 5.2 is really going to come in handy. So we know that there are 3 carbons, check. We know that there's 1 oxygen. Let's go ahead and count the hydrogens. We have the 1 here on the hydroxyl group, as well as 3 on this carbon and 3 on this carbon. That makes 7. The last hydrogen is attached to the carbon in the middle. So this is a total of 8 hydrogens. Excellent. Now, isomers, or in this case, constitutional isomers, are going to be connected differently. Here, if we were to number and name this molecule, we would see that the hydroxyl group, or the alcohol, is on the 2nd carbon. Well, what if we moved that alcohol to the 1st carbon? That would look something like this. Now this alcohol is on the 1st carbon. And we can see that the number of hydrogens hasn't changed. In total, that's 1, 2, 3, 4, 5, 6, 7, 8 total hydrogens. The number of oxygens and carbons is the same as well. So both of these molecules have the same molecular formula. They weigh the same as well, but they have different names. We can see that clearly the way that these bonds are connected, they're different. And that's an example of constitutional isomers that have similar chemical properties. I mean, they're both alcohols, it's just slightly different. Of course, if you start digging into the real chemical properties of these, such as the melting point and the boiling point, you're going to see some differences. But they both have alcohols. Now let's do another example. And let's try to find constitutional isomers with different chemical properties. So here's a smaller molecule with 2 carbons. To start, we can draw a 2-carbon chain. And we can put an oxygen on one of them. So starting like this, we have our 2 carbons and our oxygen. Let's see if the number of hydrogens adds up. That's a total of 6, so that does work. Now, here's our molecule. Here's another type of isomer that we could have. If we take that oxygen and connect it to both carbons, now both of these carbons are going to have 3 hydrogens. That's what we call the methyl group. So we have 2 methyl groups attached to an oxygen. Here we still have 2 carbons, we still have 6 hydrogens, and we still have 1 oxygen. So these are also constitutional isomers. Of course, now this one has the alcohol functional group, and this one is now an ether functional group. So these are going to have very different chemical properties. Again, they are still constitutional isomers due to having the same molecular formula. So these examples don't seem too bad. We didn't run into too many problems. But you'll see, for example, that let's say that I want to make a double bond. So 2 carbons attached that way. And then I can put my alcohol the same way. You'll see here that the hydrogens don't actually add up to the correct number. So if I include this double bond, I'm going to have 1, 2, 3, 4 hydrogens instead of 6. So this isn't going to be correct, right? Now, where many students are going to leave here with this unit is they're going to be using guess and check. And while that strategy does work for small molecules like this, once we get to larger, more challenging molecules, for example, this molecule here, C10H18O3, Let's say that I was to ask you to draw 3 different constitutional isomers of this molecule. Well, you would have to do a lot of guessing and checking. This is a big molecule, and there's 3 different structures. So now that we know what a constitutional isomer is, let's figure out a better strategy to draw them from a molecular formula. And we'll do that in our next section, section 5.2, introducing the degrees of unsaturation.